Hi everyone, we are going to see what is power amplifier and DC converters in this presentation. Let me introduce myself. I am J. Dhanashekhar, Assistant Professor, Department of ECE, Sri Ishwar College of Engineering, Coimbatore. In this presentation, we are going to cover the fifth unit of our subject Electronic Circuits 2. In that, it contains power amplifiers class A, class B, class AB, class C, power MOSFET, temperature effect, class AB power amplifier using MOSFET, DC to DC converters, buck converter, boost converter, buck boost converter, and analysis of all these converters and design of these converters. In this presentation, I am going to cover what is small signal amplifier, what is large signal amplifier, and why large signal amplifiers are required even though there is small signal amplifier, and comparison of small signal amplifier versus large signal amplifier, and what are all the parameters involved in large signal amplifier measurement, and what are the classification of power amplifiers. Now, what is actually small signal amplifier? I hope you have studied in your previous session what is actually small signal power amplifier. Small signal amplifier is nothing but it is capable of amplifying the input signal. Either it can be current or voltage, which will be in very small amount depending upon the cue point selection. Now, how we can analyze this small signal parameter is small signal amplifier is by using H parameters. So I hope you know what are all the various H parameters involved in the analysis part, that is HI, HR, HF and HO. Let us see some example of small signal amplifier. First one is common emitter amplifier, next is common collector amplifier, third one is common base amplifier, and last one is RC coupled amplifier. Last stage involves multi-stage amplifier. So first stage and second stage are connected by means of resistor and capacitor. Out of all these amplifiers, we know that common emitter configuration is used as amplifier, since efficiency of this will be very high. Now we will see what is large signal amplifier and why we want to go with this large signal amplifier. Consider a public address system, PA system. So this system will be having n number of stages. Let us consider the scenario. One person is speaking in mic in an auditorium, and there will be more number of listeners sitting inside an auditorium, and all those listeners are listening through the output produced by loudspeaker. So this was an actual case happening in a public meeting. Let us consider now the input to the mic is speech signal from that person, and the output is from loudspeaker, which will be the amplified version of the input signal, that is nothing but audio signal to the mic. Now let us consider the scenario. So small signal if we are using small signal amplifier, we can able to produce only small amount of amplification depending upon the gain of the amplifiers we are choosing. So in order to overcome this drawback, we are going with large signal amplifier, which is also called as an power amplifier. So say for example, now the input and intermediate stages are small signal amplifiers in which sufficient voltage gain is obtained by intermediate stages, hence it is called as an voltage amplifier. But the last stage is given to output to the load like loudspeaker must be capable of delivering appreciable amount of AC power to the load, hence that stage should be capable of delivering high power to the load. So that stage is called as a power amplifier stage. So power amplifier works on the DC power supply what we are giving to the circuit, and that through that power amplifier our output is given to the loudspeaker, which will be an amplified version of the input signal as represented in this present slide. Now What is actually large signal power? This is in previous slide I have explained what is large signal amplifier, how it works. Now what is the basic principle involved in this power amplifier is, from the name we can't say that power amplifier actually amplifies the power. The main reason why it is called as power amplifier is it takes the power from DC supply connected to the output circuit and converted into the useful AC signal power. In previous case, that is microphone and loudspeaker, our AC signal is nothing but the human voice which is amplified through these voltage amplifier and power amplifiers. Power amplifiers are also called as large signal amplifiers because these amplifiers use large part of the AC load line for their operation. Now let us see what are the various features involved in this large signal amplifier or power amplifier. So as I said already, input signal level is large in terms of few voltage. Output has large voltage and current, hence that it can able to handle large power. And one more thing is, in small signal amplifier we can go with H parameter analysis, but H parameter analysis is not applicable in case of power amplifier because we are having small voltage amplifier as well as power amplifier as connected in cascade. H parameter is not applicable. Impedance matching is required since we have to match voltage amplifier and power amplifier, hence it will be capable of transferring maximum power to the load. And one more thing is large power dissipation, which means you know the concept of thermal runaway. Continuation with features of power amplifier. Now we are going to see what are the various properties of power amplifier. First one is low voltage gain, which means that the gain of the voltage amplifier will be unity and current gain will be high. Output impedance of the circuit will be low and input impedance of the circuit will be high in such a way that last 2 points states that in low output impedance and high input impedance, meaning is that circuit will be operating in very safe condition. Now we will go with comparison of small signal amplifier and large signal amplifier. As I said already, transistor will be larger in size for large signal amplifier and smaller in size for small signal amplifier. That is what given as third point. And in large signal amplifier it dissipates heat. Due to this heat, thermal runaway problem will be getting occurred. As a result, transistor will get damaged very easily, so compensation is needed in case of large signal amplifier. And in small signal amplifier, if we want to go with cascading connection, then we can prefer RC coupling, which is not applicable in case of large signal amplifier. Transformer coupling is used for interconnection of stages. And with respect to load line concept, only 10% is used effectively in small signal amplifier, whereas most of the load line is used for this working condition or in large signal amplifier. And in small signal amplifier, beta, which is nothing but current gain, HFE, we have to choose beta value as larger for small signal amplifier and small for large signal amplifier. Small signal amplifier also called as voltage amplifier, and large signal amplifier are also called as power amplifiers. Next we will go with performance parameters, that is performance parameters. Performance parameters, what are all the various performance parameters that we are using? First one is nothing but circuit efficiency. What it is defined as the ability of a large signal amplifier to convert the DC power into AC power. That is given by the formula eta is equal to AC output power divided by DC input power, which states that how much amount of AC input is getting amplified with the help of DC input given through the power supply. That is what said to be as circuit efficiency. And second one is distortion. Distortion is defined as the difference between deviation or difference between output and input of the amplifier is called as a distortion. And power dissipation capacity is another parameter, which, as I said already, in case of large signal amplifier, power dissipation plays a major role. We have to measure that power in terms how much the transistor is dissipating in the form of heat. That is called as a power dissipation capacity. Next we will go with classification of large signal amplifier. So according to the mode of operation and in which location your Q point or operating point is selected, the large signal amplifiers are classified into class A power amplifier, class B power amplifier, class AB power amplifier and class C power amplifier. Let us see one by one. What is class A power amplifier? As I said in a previous slide, I have mentioned based on the operation and Q point selection, we are classifying this power amplifier. In case of class A power amplifier, transistor is biased in active region, as we have seen this concept in small signal amplifier also, and the transistor conducts for one full cycle, that is for full 360 degree of the input signal. The transistor will be in on condition and the output in, and at output we will be getting entire input, we will be getting an amplified version at the output. But in case of this class A power amplifier, efficiency is very poor, that is with respect to 25% to 50%. Why? Because transistor is biased in active region, hence the large amount of DC power is getting wasted. So in order to overcome this drawback, we are going with class B power amplifier. So before that, we will see the schematic representation of class A amplifier. As in class A amplifier, as I have said, that it is voltage amplifier, input is V in and output is V out. Voltage amplifier has a gain of AV. As in this diagram, the input signal contains one full 360 degree 0 to 360 degree input, and at the output it is an amplified version of the input signal, and we are getting for output for full 360 degree. As we are clear, we can see in this slide that there is 180 degree phase shift between input and output, which is the one parameter, which is one of the parameter of common emitter amplifier. So how we are getting this full cycle at the output is given with respect to load line. So as I said, Q point here, it is selected in the center of the load line. So as we are selecting Q point in the center of the load line, in the graph, in left hand side we are having input signal. For that, in corresponding input signal, we will be obtaining output as one full full cycle output signal. Next, we will go with class B power amplifier. In order to improve the efficiency of class A amplifier, we are going with this class B power amplifier. Here, transistor is biased in cutoff region, whereas in case of class A power amplifier, transistor is biased in active region. Here, the transistor will be in on condition for only 180 degree rather than 360 degree. So almost a small amount of Q point AC load line will be utilized. Hence, the power wastage will be getting minimized, and efficiency in respect to class B power amplifier is 78.5%, which was represented as schematically. As we can see from the graph, in load line we are not fixing that Q point in an active region. For minimizing the wastage of power, we are fixing the Q point in x-axis, that is VCE, that is called as a cutoff region, so that we are getting only one half cycle at the output, which was shown in as block diagram at rightmost graph. Next, we will go with class AB power amplifier. It is actually combination of class A and class B power amplifier. Class A, in the sense it will be operating for full cycle, whereas class B is for less than half cycle. So when we combine these two properties, we will have a class AB power amplifier. Consider the scenario. In class A amplifier, it will conducts for 360 degree, whereas in class B power amplifier, it will conduct only for 180 degree. In case of class A B power amplifier, it conducts for more than 180 degree and less than 360 degree. That is what combination, that is, it will conduct more than 180 degree and less than 360 degree. Hence, the output current flows for more than one half cycle but less than one full cycle. Here also Q point is fixed in cutoff region and efficiency is 78.5%. Next, we will go with class C power amplifier. So class C power amplifier is biased below the cutoff region by applying one reverse bias at the base emitter junction. Now here, with respect to, we can improve the efficiency in class AB power amplifier by making the transistor to conduct between more than one cycle but less than one half cycle, more than one half cycle, less than one full cycle. In that concept, here also we are going to make the transistor to conduct in cutoff region So it will be conducting for less than one half cycle. We will not get more than output current will be for less than one half cycle. So in case of class B and AB, transistor is biased in Q point is biased in cutoff region, whereas here transistor is biased below the cutoff region by giving one external supply. Hence we can achieve efficiency as 95%.